The lead platform, a quick walkthrough. The platform can serve as an impact assessment environment for simulating complex operation scenarios towards optimizing efficiency of last-mile logistics operations, evaluating alternative city logistics strategies, measuring the impact of interventions, and supporting well-informed data-driven decision and policy making. Therefore, a logistics professional or city authority stakeholder can explore how specific interventions will impact the operations and the environment. These trials could include different types of fleet vehicles, different types of last-mile network configurations, different types of delivery methods based on network configuration. As an example, in the Madrid case, the challenge was to choose the optimal setting for transforming an underground parking facility to a logistics micro-hub. The key incentive was to reduce delivery costs and the environmental impact of the last-mile logistics network in Madrid Central. Examples of what-if scenarios in this case have been: what if I move from a one-echelon network to a two-echelon network configuration? What if the demand changes? What if handling times or stop times change? The table summarizes the input and output attributes of the two models involved in the Madrid Living Lab use case. Given that the necessary datasets exist, the decision maker should be able to execute both models by feeding the output of the first model as input to the second one and get back the results needed for the different what-if scenarios. In our example with the initial conditions, number of packages, vehicles, and hour frame, we are expected to deliver 60 packages with 20 vehicles in 4 hours. Then we run the simulation, changing the stop time parameter, which is the time needed for a delivery person to get out of the vehicle, deliver the package and get back to the car. We give different values: 24 minutes, 12 minutes, 6 minutes. The simulation will calculate the total delivery distance covered by vehicles and the delivery time, the number of vehicles needed, the carbon dioxide emissions. To run a simulation, first we must integrate the models in our system. This can be done by Dockerizing the models. Our system, in order to run the model, will need to know some metadata. For example, we need to define the list of inputs and outputs. Finally, we need to tag what outputs we want to see in the results page. Here we can see the echelon model metadata. We can distinguish the input data needed in order to execute the model. Regarding the outputs, we can see the echelon model outputs that will be later presented as graphs in the results page. The users can also choose what type of chart they want their outputs to be presented in, like line, polar, area, bar charts, etc. Here we see the two models as well as the data that they will exchange. For example, the platform takes the echelon model's outputs, number of vehicles and total delivery distance, converts them to a format compatible with Capert, and then passes them on to the Capert model. And this is how it looks in the platform. We call this Functionality Scenario Builder. In this page, a modeler can connect more than one models by searching through the available models in the platform. Here we see the connection of models in the platform. Echelon is connected with Capert through a connector that transforms and passes the data from the first model to the second. The next step is the simulation configuration. Here we can see the simulation definition. Basically, a simulation is defined by using a scenario and the required inputs. In this example, the user uploads the inputs of the echelon model. The user may either upload files or select data from existing datasets. The user needs to do the same configuration for the Capert model. At the final step of the simulation configuration, the user sees an overview of the related models. Once the simulation is executed, the results are shown in graphical representations. Thank you for your attention. In the tutorials that follow, the key functionalities of the platform are presented in detail.